So, welcome to week 2. Last week I showed you some of the flying that we have. This week I'm going to go in a slightly different direction. I'm going to be talking about the dungeon generator, and by dungeon, that just means any interior space. As you can see, I don't have ceilings on this. This is the prototyperific Unity assets that I just put together to demonstrate the algorithm. A little later in the video, I'll actually show some real assets from the asset store, as real as $3 buys you, that is. But for now, I just wanted to show the algorithm and how this is laid out in general. So I'm not going to be doing much flying, but I will do some. So I'll be flying up there to show you the general layout. But before I do that, I want to show it kind of from a first-person view and from how you'll be playing it. You will be able to fly around if you have flight as a travel power. I'm also demonstrating the teleport. This is just your usual VRTK simple pointer here. I don't quite have it so it doesn't, clip you out of the zone. I'll be fixing that soon. But what this will be doing is showing kind of an outline of where you will end up when you teleport. So that's just a preview of teleportation. Once I have proper teleportation, I'll probably be doing another devlog on it. So that was back here. This is kind of the entrance room where you begin your adventure. All the indoor rooms will have a room just like this, just an entrance room, a way to come in. There may end up being like a wall here that blocks your line of sight to the rest, because all of this is generated in start. When you start it all up, the entire thing is generated. This was about 10 rooms. I've had it up to 50 without issue. So it may be fast enough, but I have kind of a beefy computer, so I want to make sure this works on machines that are not as powerful. So if it ends up that loading takes a long time, if Windows thinks it's frozen up, I may end up doing it asynchronously. So you'd be here, you wouldn't be able to see ahead because there'd be a wall in your way, and it would actually be building the rest of the maze as you go. You just kind of walk around the wall when you're ready and teleport in. So this is just a long corridor connected to another long corridor. Here we have kind of a three-way branching point. The way it came from, the way I'm going to, and this. And you'll notice this is just kind of closed off. That's for a specific reason. That's my closed off prompt. You'll be seeing it again. There it is once more. This is actually that same room, just rotated. So I'll explain how the algorithm works when I get down to the technical details. But for now, I'm just going to go through. And here you see just nothing at the end there. That's actually the end of the end of the road as far as this generation goes. So what's going to happen when the algorithm gets here is that it's going to pick one of these exits, and it's going to attach a much larger room to it. And that room is basically the boss room, wherever the objective is. If it's a multiple objective, like click X number of glowies, and by click, of course, I mean do, then they'll be back there, but the last one will be in here. So the idea is that you go through kind of a procedurally generated, procedurally generated office building, warehouse, sewers, place the superheroes go. And you make all the way to the end, and you do the thing. One thing I wanted to show, and I'll get to the technical part here. So there I am teleporting all the way. Oops. All the way here. You notice that this teleport, so that teleport's like, look how long this is. It goes way up there. It's about 10 meters. But it stops right here. If I take a step back from there, you see, it's going this far right until this. This is actually the seam between these two rooms. What's going on here is every room has a box collider. And that's preventing the rooms from being placed inside other rooms. I'll go over that when I go into the technical details. But the simple pointer is just a raycast. And raycasts, this box collider is obviously not preventing me from moving into it. But it's still interrupting the raycast. Raycasts will stop on triggers. This is just a box collider with a trigger, like anything else. See, there's not one there. I will go over the technical part, how to get around that, because it's kind of a giant pain. If you look at this, a player's going to try this and be like, why can't I only teleport 1 foot? This doesn't make any sense. Well, before I leave, I enabled flight for a reason. So this is the same flight that we had in last demo. It's not configurable or anything. So here you can see the entire thing at once. Obviously, in game, you will not be able to do this. There will be roofs on the top to prevent you from going through. But what I wanted to point out about this is that it's very linear. So you start there, you go through, and even in places like this where it could fork, it doesn't. There's a terminal one right here, and that could just easily be another room like that. You see a number of places like these are two corridors jammed up against each other, with that one just kind of moved out. So I'm going to move on into the technical portion where I describe how I actually generate this maze and how you too could do such a thing, and what kind of improvements I'm going to be doing on the algorithm, because this is decent. This makes a playable level, but I do want to do some tweaks. So till then, I'll be back in a second.
So here we see the Unity part. Now this part is basically, I'm going to get into the technical bit on how the maze is generated. And if you're not interested in that, feel free to skip ahead. Later I'll be showing off what $3 will get you in the Unity Asset Store. It will look better than my prototype blocks that you see ahead of you. But until then, I'm going to talk about how the algorithm works. So here on the left you see the game screen. That's the thing I was just walking through a few moments ago. This map I'm displaying is a different one because I've had to stop and restart this numerous times, but it still gives you the idea of how this is put together. And here's what it looks like from above. You see it's very similar to what I showed when I was in-game earlier. However, you see all these other things on the screen. There's the point lights, obviously, but you see this thing that says spawn, for instance. How this works, this is the interior builder. That's the script, interior builder script here, that does all of the work. How it does that is you give it a start room, and in this case it's this proto start right here. That one. It starts from there. It chooses, so what this room looks like, I'll open up the prefabs here for that particular one, the proto start. What this looks like when it's not in-game is this. You have this spawn point right here, and this is just an empty game object that is tagged respawn. You've got the things that make it up, and you have this other tag. This, again, another empty game object. I just give it a gizmo so I can see where it is. And this has a script called exit tag. What that script does is it says this part is an exit. Use this part to connect to other rooms. And how that works is the game will look at the room. It will look at all the exits from the room. In this case, there's just the one. It will pick one of those exits as moving to the next room. Again, the layout of my maze is very linear. So it only picks one to move on, and the rest of the exits it will just put filler. It'll either block it off completely or add a room that has no other exits to it, like this one. In this case, since there's only one exit, it will pick that. Then it will pick a room that fits that door. And I'll talk a little bit about what fitting that door means. For right now, all the doors are the same size, so it doesn't matter. Here you can actually see I can set that tag size to large or small. When I do the demo later, I'll show what that means. But for now, it'll look at that tag, it'll look through all the ones that the interior builder has, and here you see I give it a number of possible rooms, and it will pick one that fits that tag. So let me drag another one off here, this corridor here. So this corridor is a simple north-south corridor. See, it's very similar to the room we had before because I mostly copied and pasted it. But the big difference is now we see that there are two exit tags. There's exit tag north and exit tag south. And the north-south doesn't actually matter. They're just names I use to keep them apart. This exit tag north could actually connect to either of these. The important thing to notice is the gizmos on there. You see exit tag south is oriented like this. The positive Z is pointing this way. This exit tag north, the positive Z is pointing this way. Here, same thing. The reason it does that is so that it knows which direction to orient this. If it decides it's going to connect this exit tag north to this exit tag south, all it has to do is make sure that those are pointing toward each other, which they already are, and then move one so it's on top of the other one. However, for this one, if it's matching up these two exit tag norths, one of them, this one, is going to be rotated 128 degrees. That'll rotate the entire room. Later, again, I'll be showing instances of the same room reused. That's how that works. It's reused from a different angle because it picked a different exit. So this exit tag north is going to be matched up with any of these exits in this room. First it picks a room, then it picks an exit in that room. And it continues to do that. That is the entire algorithm. All it does is it finds an exit, it picks an exit, and it does something with it. I'll go a little further in with the multi-exit rooms right here. So we see this room, Proto Corridor 3. It has this exit tag, which was hooked up to the exit tag here. So that's, that's one of the instances where they're north-south, and south got hooked up to west. It turned. Normally this one is actually oriented about 90 degrees the other direction, and hooked it up there. Then it said, okay, one of the remaining exits, it doesn't pick the same exit again, needs to be the correct one, the one that leads to the rest, which is this one, and one of them needs to be one that just doesn't go anywhere. Here it's actually reusing that original room that we had. That's a valid room to reuse, so the spawn doesn't mean anything. In the future, I'll actually have spawn points in every room, things like enemies, mission objectives, even just props. For now, all it does is it says, okay, this, I'm just going to put some terminal room in there, and on the other one, I'm going to put another room, and then I'm going to continue, and continue. And here's another through. This is actually, this room here is the same room as this room here. It's just been turned in order to match up these tags. And again, one of them, it just closes off. It picks a room with no other exits. The other one, it goes here. Here, same thing. This room and this room are also exactly the same. Easier to see from this perspective. It picks a different room to close it off. This is just a wall with one tag on it that says, this tag, this is just the only exit for this. Looks like this. And that's it. It has that one tag. So this is a really easy way to close things off without taking up a lot of room. Because the other thing that happens, and again, I'll be demonstrating this with the other assets, is that when it places this room, it's going to check. You see there's a box collider right here. It will check to see if that box collider collides with any other box collider. So if this had decided to put a room here, and then that room had decided to put a room here, it would see that they'd overlap, and it would back up. And I'll demonstrate a little bit later what the ramifications of that can be and why it's not exactly perfect. You see it does that all the way until it gets to the very last room, and then that's our terminal room that I showed before. And here's where we'd probably put some kind of boss room if possible. The other thing I wanted to mention, I pointed out briefly in the previous video the weirdness that these box colliders cause. Even when I use Unity Asset Store props, I've added box colliders to them for this overlap kind of testing. The problem with these box colliders is you saw the ray that you cast from the controller is intercepted by these. It can't go through these. And I can't mark this room as, this room has the box collider. I can't mark it as ignore raycast, because then the entire room would be ignore raycast. The pointer would go through the entire room, which would render it useless. However, the solution to this is actually, it's a setting. So it's an edit, project settings, physics, and over here on the right, queries hit triggers. If this is on, it will hit this box collider that should have been marked as a trigger. That might also have been part of my problem. If it isn't on, then it will completely ignore those. So that's what you want to do. You want to make it so that the queries do not hit triggers, because really there's no good reason for the raycast to hit to hit a collider that's also a trigger. That's it for the technical explanation. In just a bit, I'm going to show what this exact same algorithm can do with actual assets from the Unity store. Because this prototype, while interesting looking, will probably not make it into the final game unless I need kind of a VR looking area.
Behold what $3 on the Unity store will get you. And yet, it's so much better than my art. So, this was labeled modular, but it's not necessarily so. You will see some weird stuff, like where it doesn't quite fit together, / where I haven't completely bothered to fit it together. And you will see some incomplete items like this. The reason I did this is because I'll show later, the algorithm tries to avoid overlapping rooms. Some of the end caps, I do have fancier end caps than this, and I will be showing them, but they're fairly big. They have a lot of depth, and I'll be demonstrating why that's an issue a little later. This, very, comparatively small, rather thin. So if I absolutely positively need to cap something off, this is what I do with it. The other thing I wanted to point out from the algorithm point of view, I showed the tags in just a little bit ago. There's one there and one here, and it lines them up. Ditto here, one here, lines them up. But the really interesting thing is, this door is obviously hugely different than this one. If I matched, this small door to this large one, it would look terrible. Not to mention, there's no backface. There's a ton of backface culling, so you'd be able to see right into the other room. It would not look good at all. So each exit tag actually says the size. The algorithm knows to match small to small and large to large. Also, I still included flying because it's fun, and I'll be demonstrating it later. So here is another one of the end caps I was talking about. Whereas before, it was very thin and just that. Here, there's actually some depth. You can go into it a little bit. It may be able to spawn, a mission objective or an enemy or something along those lines. And the other thing about this is I'm getting double use out of it. So watch me cheat. Whoop. There's a dupe of this prefab that has a tag right there that says that's the entrance. So it'll turn it around. And you see this is just as closed off as this side. Need to be able to do something about players doing this. But for now, it's just a demonstration. And here you can kind of see that it doesn't really match up with the rest of the assets. But again, $3. I got my money's worth. So you can see the algorithm at work here. It matches this large one up to this large one up to that large one, and this one up to an end because it needed to cap that off, because it decided this was the way to go. Almost the exact same thing happening here. This is actually the same room as over here. There's a corridor in between. You can see it's matched this small door with the small block to block it off. It could have just picked another big room. The reason it didn't is probably because it would have collided with this. So that's kind of the collision algorithm in action. So this room is the exact same as that over there, but it's been rotated. You'll see that a lot because it just picks two at random, rotates them to fit, and moves on. So that's the same thing again. It's blocked off. I'll point out why that's a problem in just a little bit. Same thing here. This is, again, the same room. I don't have a room with 4 exits, just 3, because the 4 exit room, it doesn't pivot on its center, which makes it enormously problematic to try to line up. Again. And here we have another instance of a small room being mated to another small room. That's actually what it's called in the code. Don't blame me, I didn't write. Oh, I did write it. You see some Z fighting there because I haven't lined that up right. If I line it up correctly, there's a huge gap in between there. But I wanted to point out this right here. We have another blocked off end cap area, one that's a big one. That becomes a problem here. So this is the terminal room, where after this, the algorithm would put a big boss room. Problem with that is, you see, that's the end cap right over there. If I try to put a big room here, it's going to collide with that, and it's going to fail. And because of the terminal room, there's no other kind of room to put here. So it's going to keep trying to put the boss room and keep failing. Right now, the algorithm will just completely bail, and you'll end up with something that looks exactly like this. In the future, it'll probably backtrack. It'll remove this room and try to put a boss room here where there's a bit more room. Here you can see what I said about backface culling. You can see right into these if you get outside of the environment. That wasn't the case in the other one. I imagine Unity assets are all going to have this sort of thing. So getting outside the map may be more difficult. All right, I'm going to do a little more flying while I'm outside of the map. This is what it looks like. So here you can kind of see this one is a particularly great random generation because it outlines my goals with the maze generator perfectly. This is linear. Right? You started there, you take one path to the end. But it sure doesn't look linear. It sure doesn't feel linear. You get all the benefits of the action. You can just go through, fight all the enemies without getting all the way here and being like, oh, wait, turns out the boss is way back there. Not a problem. It's always going to be at the end. There is a setting in the algorithm to increase the, I believe I call it the branchability. And what that does is, an end cap like this would actually have a corridor, and then that would be end capped. But for right now, this is just a demonstration of what I can do. So, next week, I'll probably be trying to spawn some things or work on that branchability that I mentioned. Either way, it should be an improvement over what's happening right now. Every week, we'll get a little closer to having a superhero game where you can run around and beat people up. Until then, goodbye.